Okay. Okay. Okay, so for student here, so as I said, we will. So in my class in the future, I will continuously post some MCQ, so to just to help you rehearse. Hello. So just to help you rehearse how the quiz question looks like. So some questions look like this. So could you, so this is learning catalytics. I think most of you have already used this for your last semester physics class, right? So could you help me take a look? So this is the session ID. Whether you can see this question with this session ID. Could you help me take a look? Yeah, you can log in Clinical Analytics directly through our course site. So it's not our tutorial, it's a whole, the whole TL course. So there is a master learning physics there. So for student online, so you can see the question I posted here. This question also available in Learning Catalytics with session ID given by this number. Okay, with session ID given by this number. Could you take a look whether you can see the question I posted there? Student online. Can you see?
Yes, you can see, Prof.
Also, it's there, right? Okay, good. So this is this one we will just try one. So if it works well, and then for next class, next tutorial, maybe I will have more such a question. Help me just to interact with me to how to say, to try some examples during the class. Okay. Oh, I think 2 weeks later or tutorial on Wednesday. 2 weeks later on Wednesday, I think it's a public holiday, if I remember correctly. So because of the Chinese New Year. So that, I'd like to ask, so also the student online, so I would like to ask everyone whether you would like to conduct the class exactly as it was scheduled, for example, on Wednesday afternoon, or we should schedule another time. A schedule and time we need to fix a date where everyone is available. Otherwise, we can only conduct a public holiday. So what's your opinion? Yes, student online, my question is 2 weeks later, all class 2 weeks later on Wednesday, it's a public holiday, Chinese New Year, okay? So would you like me to still conduct the class, as it was scheduled? Or we do a makeup class? Any idea? What do you think? Sorry? Whether we should reschedule. So if no response, which means we will still conduct as scheduled. So no one have objection, right? So if we conduct the class 2 weeks later on public holiday, so anyone have an issue? No issue. Okay. So that we will still conduct the hybrid mode. Okay. I will still conduct the class in this tutorial room, but you are allowed to attend online. So even the students, you are scheduled to come to attend on site. You don't have to come. You can stay online. So if you are not, maybe I will just sit here and conduct online class. But if there is still student coming to this classroom, maybe we will still conduct in hybrid mode. But anyway, 2 weeks later, I think it's group B, right? Still this group. So if you think it's public holiday, you just want to stay at home this 1.5 hours with your family, you don't want to come to school, it's okay. So we don't have attendance marking, something like that. So that, but we will still conduct the class as it was scheduled. Because I think it will be difficult to find another help to satisfy the, to accommodate all the students. Okay? Clear? So for student on site, online, in team, so no issue, right? We still 2 weeks later, we still conduct the class. We still conduct the class as it was scheduled. We will not do a makeup class because otherwise it will be difficult to find another common time for all students. Okay, good afternoon, ladies and gents. Okay, so now let's start our class. Oh, sorry, I have to first do this. I have to first let me start the recording before we actually start. Okay. Oh, recording already started. Okay, thank you. Okay, yes. So this is our second class. So that we will continue to talk about the geometrical optics. So for students attending on team, so as I said, if there is any frozen of my voice or my slides, you just unmute yourself and let me know. Okay, let me know. So just like what we do for the last class, because if there is any internal problem that I cannot support, that you just let me know. Okay. So for our second class, we are going to learn image formed by mirror and lens. So as you can see, there are two parts. Okay, here we have two parts. One is image formed by mirror and lens. So if you have already attended, I think the summary lecture is scheduled last evening night. Every Tuesday evening. How many of you have attended the summary lecture? Okay, only half. How do you find it? Do you think it's easy to follow or quite difficult?
Easier than the lens.
Okay, easier than the lens. That's good. So that if you watch the last video, I think most of you may have already found the yes, you already found that there are actually many concepts there. But what I would like to let you know is for tutorial 2, for this chapter 2, all the content can be summarized as 4 questions and 2 tables. The most important concepts are just 2 formulas, 2 equations. Oh, sorry, 4 equations and 2 tables. 2 equations for mirror and 2 equations and 1 table for mirror. Another 2 equations and 1 table for lens. So let's look at what these 2 equations for mirror are. So first, what we have already learned, if we place light source or an object in front of a mirror, for example, this concave mirror, okay, this is a concave mirror, and then light emitted from, for example, one point of the light source upon reflected by the mirror, okay, upon reflected by the mirror, for example, this 2 light ray will intersect, will focus at one point. At one point, once the light is focused, we will see an image. We will see an image. Okay, so this is what we call image by mirror. Normally, image by mirror is upon reflection from this reflecting mirror. Okay, from this reflecting mirror. So that what we are interested in knowing is the distance of the object to the lens and the distance from the image, to the mirror, and the distance from the image to the mirror. So if we define the distance between the object and, for example, the center of this mirror as P, the distance between the image, for example, this B prime to the center of the mirror as Q, and then what people found this 1 divided by P, the object distance, okay? The object distance is the distance between the object and the mirror, while image distance is the distance between the image, okay, the image and the mirror. For example, this BO is my object distance. B prime O is my image distance. So that, of course, we can place the object at any position we want, right? By moving it forward and backward, we can locate it at different position. In this case, the position of the image will also change. But in experiment, what people found, no matter how P and Q change, 1 divided by P plus 1 divided by Q is always a constant. It's always a constant. And this constant is 1 divided by F. F is the focal length of this mirror. Focal length of this mirror. So that this guy here is always a constant. Only depends on the geometry of this mirror. So that's the first one is the most important equation for image by mirror. What we call the image equation. This is the image equation. So as I said, F is only a function of the geometry. So mathematically, it's just equal to R divided by Q. So if you already attend the length or the summary lecture, this R is what we call the radius of curvature. Okay, the radius of curvature. What does the radius of curvature mean? Because here we have a concave mirror. Okay, so concave mirror is actually a part of a sphere. So if you consider we have a whole sphere or a whole circle here, and the radius of this circle is what we call the radius of curvature. Okay, the radius of curvature of this curved surface. So F is always 1/2 of that radius. Okay, so these are the 2 important equations for image by mirror. So first, the 1 divided by P, object distance, plus 1 divided by Q, the image distance, always equal to a constant. This constant is 1 divided by F, the focal length. And the focal length is only a parameter of the geometry, which is 1/2 of the radius of curvature. Okay, any question here? So if no question, now we will come to the table. So that in order to apply the image equation, we have certain sign conversion. Sign conversion, which means when P, Q, and F are positive or negative. Okay, so we have a table for the sign conversion. These 2 questions you will found in your formula sheet. For example, when you attend the final examination or quiz, we will be giving you a formula sheet, and these two formulas are provided there. Okay, are provided there. So that you just have to understand it. No need to remember. But the table here is what you have to remember. Okay, the sound conversion will not be provided in the formula sheet. You have to remember. So how when P, Q, F, and R are positive and negative? So here for mirror, as I said, when P, Q, F, and R, when they are positive or negative, this depends on the incident direction of light. Incident direction of light. Now here, if we assume light is traveling from left to the right, as this is for most of the case, and then the object distance will be positive if the object is located on the left-hand side of this mirror. If the object falls on the right-hand side of the mirror, that will be a negative. That will be a negative P. Positive P always can respond to virtual object, while negative P always can respond to, positive P always can respond to real object, while negative object distance always virtual object. Okay, so this also applies for the image distance. If the final image form here is on the left-hand side, of the mirror, and then we will get a positive Q, positive image distance can respond to real image. If this guy appears on the right-hand side of the mirror, so which means actually it's formed by the extension of a virtual ray, so it formed on the right-hand side of the mirror, then we will get a virtual image can respond to negative image distance. So you can say both P and Q are positive on the left-hand side, right? So are negative on the right-hand side. On the left, positive P and Q can respond to real object and real image. On the right-hand side, that's negative P and Q correspondingly we get virtual object and virtual image. Okay, so this is for PQ the definition. Okay, so focal length and R is defined if it's concave towards the left, towards the incident direction, then we will have positive F and positive R. If it's convex, so for example, if we have a mirror in this way, right? It's convex. Oh, sorry. Convex towards the left, and then that will correspond to negative F and the negative R. Okay, negative F and the negative R. So concave mirror here, we also call this focus mirror. Okay, focus mirror. And the convex one, we call that divergent. Okay, it's divergent mirror. Okay, so this is for sound conversion for P, Q, F, and R. Any question? Any question? Okay, no question. Let's continue for length. So for length, actually we have similar. One is the image equation. One is how the focal length is defined. So for length, the image. So for length, actually the image. So length can form an image by refraction. When light passing through this, for example, curved refractive material, so upon the transmission side, light will be refracted and then focus at another point to form an image. So that allows image to form on the right-hand side of this lens. So that if we define still the distance between the object and the lens as Q1 here, and the distance between the image and the lens as for example Q2 here, and then 1 divided by P1 plus 1 divided by Q2 will equal to a constant. And this constant is also 1 divided by F, the focal length. So this question is more or less the same as the image equation. Okay, this formula is more or less the same as the image equation for mirror. But how F is defined is different. For mirror, F is very simple. Just R divided by Q, right? But for length, the F will be given by the length maker's equation. So which is this guy, the second equation. 1 divided by f equal to n minus 1 times 1 divided by r1 minus 1 divided by r2. Okay, so you can say now the focal length depends on both r1, r2, and n. So n here is the refractive index of this length. Okay, n here is the refractive index of this length. R1 and R2 are the radius of curvature for the left and the right. For the left and the right surface. So according to the length matrix equation, you can say we can change the focal length by either change the refractive index or the radius of curvature of the two surfaces. So that, but for mirror, we can only change the focal length by changing the geometry of the mirror, right? Only the radius of curvature. So for length here, apart from changing the radius of curvature, we can also change the refractive index. So that here we have more freedom. So this is why in most of the case, lengths are more often in, for example, in our camera system, not mirror. Okay, but here one thing I would like to highlight to you is this n minus 1. So it's the refractive index of the length minus the refractive index of the background. Here the background is assumed to be air, so that we have n minus 1. Everyone take a note down. Okay, there are quiz question tests about this. Okay, now if I place the same length in water, can you guess what will happen? How should I modify this equation? If I place this in water, then the length matrix equation will change. How should I change it? Okay, what I should do here is I need to change this one to the refractive index of the background. Okay, so you can say in your formula sheet, why I still provide this formula is because in the formula sheet you are given this formula. Okay, it's not n, for example, minus n prime. But what I should say, the most general form is not n minus 1, is n minus n background. N length or n length refractive index of this length minus the refractive index of the background. Okay, so now if you place a length in water, or for example another kind of your material transparent such as glass or alcohol, something like that. Okay, in this case you need to change this n minus 1 to n minus the refractive index of the background. Okay, so this is what you should do. So any question about these two equations? Okay, if now let's look at the sign conversion for the length. So as I said, positive P always a real object, negative P always a virtual object. So image is the same. Positive image distance is real image. Negative image distance is a virtual image. Okay, but now, so that for sign conversion, okay, the P object distance is still defined the same. If we assume light traveling from the left to the right, and then P are positive on the left, negative on the right. But now Q is defined in a reversed way. Now Q will be positive on the right hand side, while negative on the left hand side. So now right hand side positive Q, real image. Left hand side, negative Q, virtual image. So F now is positive for converging length. So which means if F is larger than 0, we have a converging length. If F is smaller than 0, we have a diverging length. And this shape of length is a typical converging length. Now if we have a length, the left is concave, the right hand side is convex, that is diverging length. Why? We now have to come to the definition of the radius of the mirror. Okay, radius of the mirror. So that the radius is positive if it is convex towards the left. So this is also different from the mirror. Mirror is always concave towards the left, towards the incident direction. We have positive. But for length, convex one will have positive radius. Concave one we will have negative. Okay, so that for this kind of shape, you can say my R1 is convex, so R1 is positive. R2 concave, so that R2 is negative. Positive number minus negative number will make the second part more positive. So that the refractive index is normally larger than 1. So that when we have this left convex, right concave, we will get a positive F that is focusing length. Now if you switch this, the left surface become concave, right surface become convex. So now it will be a negative number minus a positive number, which will make the second part, okay, even more negative. So that way we will get a negative F corresponding to divergent F. Okay? So any question? So if no question, let's continue for the last part, okay, about the summary, the property of the mirror. So if you already look at the tutorial question, okay, you will see many questions actually asking for to first locate the position of the image and then commonize the property. So property is whether it's real, virtual, whether it's enlarged or minimized or reduced image, something like that. So that whether the image is real or virtual, you just look at the image distance. If the image distance is larger than 0, that is a real image. Smaller than 0 is a virtual image. Only depends on the sign of Q. Okay. While whether the object is inverted or upright, so it's magnified or minimized or reduced, depends on the magnification. If the magnification element, so which is minus object image distance divided by the object distance, then it is minus Q divided by P. If this guy is larger than 0, we get an upright image. Smaller than 0, we get an inverted one. Okay, we get an inverted one. So yeah, that's all about the summary. As I said, we have two equations for one table for sign conversion for Vivo. Another two equations and one table for sign conversion for length. These are the most important concepts of chapter 2. As long as you can understand the 5 slides I provided here, I think you are fine with chapter 2, okay? But if you find something unclear and you have to read the lectures again, if you still have questions, you can consult me on this Friday afternoon, okay? So do not let questions continue to the future, okay? Try to clear your doubts, just within the week, because I have this consultation session every Friday afternoon, okay? So now let's look at the tutorial question. So tutorial question 1 here, we have the height of a real image, okay, real image, which means its Q should be positive, okay, formed by a concave mirror, and the height of this real image is 4 times of the height of the object, and then we know the object distance P is 30 centimeters. Then the question asks what is the radius of curvature? Okay, as I said, radius of curvature just twice of the focal length. And then use the ray diagram to locate this image. Okay, to find out where the image will be formed. So that, of course, this question tests us to apply the image equation for the mirror. So that R is equal, radius of curvature is equal to twice of the focal length, right? So in other words, we should use the image equation to first find out the focal length. Right, 1 divided by G plus 1 divided by Q equal to 1 divided by F. This is what we should apply. So which means there are two equations, okay? You can say there are three parameters within the image equation. Knowing only 2 out of the 3 parameters, we will be able to determine the third one. Okay, the third one. So that if you want to determine F, we should know both P and Q. But this question only gives us the object distance P. So that if you want to find the focal length, you must find another condition to locate the object distance, the image distance Q. So which condition should we use to locate the image distance Q? Which? Any idea? Yeah, very good. Thank you. we should use the height of the image is 4 times of the object. So which means now my magnification, the magnitude of my magnification should be 4. But bear in mind, okay, magnification equal to minus Q divided by P. So this minus sign is actually regarding to its upright or inverted. Okay, upright or inverted. Minus Q divided by P. Because we have both real image and the real object here. Okay, so which means Q divided by P should always be positive number. Minus of this positive number, we should get a negative number. Okay, so although the image height is 4 times of the object, but here our magnification should be minus 4, right? First, the magnitude of this magnification should be 4, so that can make the height of the image 4 times of the object, 4 times of the object. But because of this minus sign, P and Q are both positive, so that way magnification equal to minus 4. So that Q should be minus P times this M. Okay, so we get Q equal to 120 centimeters. Once P and Q are given, and then we can directly use the image equation 1 divided by P plus 1 divided by Q equal to 1 divided by F. 1 divided by F is 2 divided by R. So that P and Q are given, we can directly calculate my R is equal to 48 centimeters. 48 centimeters. So F focal length should be 22. Okay. Should be 24. Sorry, not 22. 24. So then the second part is how to locate the image. Okay, how to locate the image. So here we have an object here located at 30 centimeters to this mirror. So this distance is 30 centimeters. So we first find out where the focal length it is. So we already calculated the center of curvature. Okay, center of curvature is about 48 centimeters. 1/2 it is the focal point. Okay, focal point. So the focal point is the focal point to the length. This is the focal length. Okay, and the 24 here is the focal length. So F is my focal point. Then if you want to locate the position of this image of this object, what we should do is we need to find out the intersection of light emitted by the object or by the top of the object. Normally we can have, we just need two light rays to use in order to get the position of the image. So that according to the lecture notes, the first ray we should draw is the light ray that is emitted by the object parallel to the horizontal axis. For this kind of light ray, upon reflection, it will always pass the focal line. Okay, it will always pass the focal point. So that this is how the reflected light ray will go. So the second light ray, we can assume the light is emitted to the center of the lens here. So according to what we learned in the NUMS, in NUMS, upon reflection, the reflected light ray and the incident light ray will be symmetrically distributed across the horizontal axis. So which means the horizontal axis will bisect the incident and the reflected light ray. And then the intersection point of these two rays will give us a position of the image. Or here you can use another ray that is emitted passing through the focal length. Okay, passes through the focal length, and then upon reflection, it will be parallel to the horizontal axis. We will also intersect at this point. Okay. So using only two rays of the, of this special ray, you will be able to locate the image. So this is what you should draw in order to locate the image here. Okay. Any question? Any question? So if no question, now let's continue. So here we have a concave mirror whose radius of curvature is 20 centimeters. So radius of curvature 20, so focal length is how much? 10, right? Because focal length is 1/2 of the radius of curvature. Okay? The question asks us to find out the image distance for 3 cases, where the object distance is 40, 20, and 10 centimeters. For each case, state whether the image is real, virtual, upright, or inverted. Find out the corresponding magnifications. Okay, so this is the case we are looking at. We have radius of curvature equal to 20, focal length equal to 10, P equal to 40, 20, and 10 centimeters. Find out the corresponding image distance for each case. So now let's start with the 41. So apply. So bear in mind both my radius of curvature and the object distance are larger than 0, positive. Okay. So first I rearrange because what I want to calculate is my image distance. So that I first rearrange the image equation. I make PQ. So 1 divided by P plus 1 divided by Q equal to 1 divided by F. So that I rearrange. Put this 1 divided by P on the right hand side. So that when it's equal to 40, I can get my Q is about 30.3 centimeters. 30.3 centimeters. Okay, this is where, so this is real or virtual image. In this case, real or virtual? Real. Very good, real, because Q is larger than 0. As I said, whether it's real or virtual only depends on the sign of Q. Okay, the sign of Q. Magnification equal to minus Q divided by P, so which is minus 1 over 3. Okay. Minus 1 over 3. So minus sign, minus magnification, which means it's uninverted. Okay, it's uninverted. And the magnitude of m is smaller than 1, which means I should have a reduced image. Reduce the image. So that in this case, we should comment the image is 30 centimeters in front of the mirror. So it's real inverted and reduced with a magnification of 0.33. So 1/3. Okay, 1 over 3. So if we have a single mirror or single lens, the real image is always inverted, while virtual image is always upright. Because it's minus Q divided by P. If it's a real image, which means my PQ are both positive, of course, it's a minus magnification, it's inverted. Virtual image, okay, Q is negative, minus will bring the whole magnification to positive, so we'll use it apply. But this only apply for single lens or single mirror. If we have a cascading lens and mirror and then compare the first and the final image, you know such law does not apply. But for a single lens and single mirror, always real inverted and virtual upright. Okay, virtual upright. Now let's look at the second case where my P become 20. So P become 20, we just update the P here to 20 centimeters. And then you will get now my Q is equal to 20 centimeters, also 20 centimeters. Positive one, which means it's a real image. When you find out that magnification is -1, so that this is also a real image. Real image, okay? And it's equal size. -1, which means it's inverted, okay? It's inverted. So bear in mind here, my Q is equal to 20, okay, equal to 20. The same as the object distance, okay? Here is twice of the focal length. We will get an equal size inverted real image. Real image. The final case is my P become 10, the same as the focal length. So that in this case, we get 1 divided by Q equal to 0. Then my Q go to infinity. Q go to infinity means what? What does Q go to infinity mean? The image is formed at infinity, or no image can be formed because we cannot capture where the image is. It is at infinity. So that when Q go to infinity, no image can be formed in this case because all the reflect vectors are parallel to each other. No image can be formed in this case. Okay, no image can be formed in this case. So now for this question, I will give you a very important conclusion about the image property formed by this mirror lens. Okay, those are right. For this concave mirror and the convex or converging lens. So that this conclusion will not be provided in your computer sheet, but it's very important. I hope every of you can remember this. When you remember this, you will quickly save your time to solve the quiz and final examination question. Okay, this is an important conclusion because there are many quizzes, especially questions talk about this. Okay, talk about this. So when you locate, for example, the object at a certain distance with respect to the length and the what will be the property of the image. If you can remember, for example, all the 5 points here, and then it will greatly save your time to solve the quiz. So we will have an example later. Okay. So first, if we have a concave mirror or convex lens, or this converging lens, we can form both real and virtual image depending on the object distance p. If the object distance is larger than the focal length, we will form real image. Okay, we will form real image. But whether this image is upright or is enlarged or reduced, and then depends on how far they are from the lens. If my p is larger than twice of the focal length, the real image is reduced. As I said, real image is always inverted, okay, always inverted. So that if p is larger than twice of f, we will get a real inverted and reduced image. If p just equal to twice of the focal length, this real image will be equal size. Again, still inverted, okay? If it's between one of the focal lengths and twice of the focal lengths, and then this image waveform, it will be an enlarged one. Okay, so that the real image can be formed in these 3 cases. Larger than means very far from the length of zero. Larger than twice of the focal length, we get a reduced real image. Just the twice of the focal length is actually equal size real image. Between f and 2f, we get an enlarged real image. As I said, real image will always inverted. So p equal to f, no image can be formed because reflected light they are all parallel to each other. So if p is now smaller than the focal length, and then we will get a virtual image. So virtual image is applied. Remember, for converging lens or concave mirror, the virtual image waveform is always enlarged, not reduced. Always enlarged. Okay? So this is the virtual image formed by the concave mirror or convex lens. Okay? So if we have convex mirror or this diverging lens, okay, this diverging lens. So what we will get is always a virtual image. Okay, in this case, this kind of mirror and lens can only form virtual image. And the virtual image formed by this diverging lens or convex, okay, convex mirror is always virtual, reduced. Okay, this virtual image is reduced now. Okay, so the previous case real image is always enlarged now. Always enlarged now. Okay, as I said, virtual image always applies. So now if you remember the property of these 2 lengths, and then you can solve actually some physical question. So there are some physical questions looks like this. So here we have an image and mirror in the figure below. Based on the appearance, I want you to comment on whether the image is concave or convex. For the mirror is concave or convex, and the image is real or virtual. Okay, I will give you 3 minutes to look at this question and submit your answer. Yeah. Give you 3 minutes. Okay. Try to submit your answer on learning analytics. Okay, log in and submit your answer. So the session ID is already present here. You just log into from our course site and then see the question posted there. You can submit your answer. Okay. Take a look. So from whether it's upright or inverted, you can judge whether it's real or virtual. And then this is concave or convex, and then from the size of the image. Okay. Look at how many of you submit. So last 1 minute, try to submit your answer, okay? Okay, so thumbs up. Let's look at the answer. So first, you can see the image is upright, right? As I said, for a single mirror, upright image is always virtual. It's always virtual. Okay. So that we can only live with B on the D. B on the D. Whether it's concave or convex, as I said, concave mirror will always form an enlarged, magnified image, while convex one always reduce in virtual image. Okay. Clearly, the image, the person inside the mirror is enlarged. So that can only correspond to concave mirror. So that here we should choose B. We should choose B. Okay. Any question? Yeah, any question? So yeah, good. If no question, let's continue. Okay. So now this will be lens. Okay. Here we have a transparent photographic slide placed in front of a converging lens, whose focal length is 2.44 centimeters. So f length is 2.44. The lens forms an image of the slide, and the image on the slide, which is the object. The image between the slide and the object is 12.9 centimeters. The question asks us to find the arm to the object distance. The object distance of the slide to the mirror to the lens. If the object is A virtual or D virtual. Okay, so in order to solve this question, we need to understand it. So first, for real image, you should bear in mind both F and P are positive. Okay, for real image, like Q is also positive, and the image is found on the right hand side of the lens. Is found on the right hand side of this lens. Okay, now in order to solve for P and Q, okay, for P and Q, we need to apply the image equation. But the question does not directly tell us which image distance we have. We need to find out by ourselves. So here we know the focal length. We also know the distance between the object and the image is 12.9 centimeters. So which means in this case, my P plus Q, okay, should be 12.9. Right? My P plus Q is equal to 12.9. Okay. Then this is the first equation from the question. Object and the image is 12.9, so which means that P plus Q is 12.9. Another equation between P and Q is of course obtained via this image equation. 1 divided by P plus 1 divided by Q equal to 1 divided by F. Now P plus Q equal to 12.9, which means my Q can be written as 12.9 minus P. Now you can see in this equation we only have one undetermined parameter. Only one unknown parameter, which is my P. So that rearrange it, we can get a quadratic equation. We can get a quadratic equation for P. So which means the quadratic equation here, we can get two solutions for P. Okay. Now P, for both P, okay, you can say 12.9 minus both guys, we can get a real image. We can get a positive Q. So it corresponds to real image. So which means both solutions are valid. Okay. Which means both solutions are valid. Okay. So any question about this one? This is kind of realized. Now we should we should look at the second case. The second case is more interesting here. It's more interesting because we have a virtual image form. Virtual image corresponds to my Q smaller than there. Q smaller than there. Okay. So that in this case, my image is formed on the left hand side of the lens. So which means now this is my object distance P, and now this is my virtual image. Okay, the distance from to the length is q. But now here I have this question for you. You can say from this, should I write? You can say question tell us is the distance between the image and the object is 12.9. So now it's this distance is equal to 12.9. Then so which means you can say my all image distance q, right, should now be 12.9 plus the object distance p. But should this distance q here, this distance is q or minus q? Or should I use q equal to p plus 12.9 or minus q equal to p plus 12.9? Which equation is the right one? So this is some important part. Which equation is the right one? First or second one?
Second one.
Very good. Second one, because Q we have this sum conversion because we want to apply this universal image equation. But the real distance between the image and the mass is actually absolute value of Q, not direct Q. Q is called the image distance. But it does not, when we measure the distance, we cannot measure whether it's negative or positive. The sign conversion of Q here is only because we want to satisfy the image equation. But when we want to measure the real image distance, what we get is the absolute value of Q. So now, bear in mind, virtual image, what we get from the image equation, Q is negative. Q is negative, but the distance should be a positive number. So that's the real distance between the image and the object. The image and the length should be minus Q. Only minus Q can be a positive number, right? P is positive, of course, we have an object, real object. So P positive number plus 12.9 is another positive number. So if you want to make a positive number equal to, for example, a certain distance, this should be minus Q. So otherwise, you can say the first equation is actually, does not self-consistent, because the right-hand side of the equation is positive, but the Q is negative. How can a negative number equal to a positive number? Okay, so now here we should choose minus Q. The reason for us choosing minus Q is because now minus Q for virtual image is the real distance between the image and the length. This is something you have to bear in mind. Okay. So this is a tricky part here. This is a tricky part here, so that you have to remember, understand this. Now the same, we can replace Q by P in the image equation. As I said, first one is wrong because negative number cannot equal to a real number. Only we should choose the second one. So that we again substitute Q by P, in the image equation, rearrange it, we will get another quadratic equation. Solve it, you can get P equal to either 2.1 centimeters or minus 15 centimeters. So that we have a real object, so that we should draw the negative solution. We should draw the negative solution and then keep only the positive one. Only the positive one. Okay? Any question here? Any question? Okay, so if no question, let's look at one of the past examination paper. Okay, one of the past examination paper. So this is very similar to this tutorial I have tested in the academic year 2000, semester 2, 2018. Okay, so here consider a concave mirror with a radius of curvature equal to 4 centimeters. So it's a concave mirror. So the F is 1/2 of the radius of curvature equal to 2 centimeters. Okay. An object placed in front of the mirror at a distance that is shorter than the radius of curvature. Okay, so the object distance P is smaller than 4 centimeters. Okay, because it says smaller than the radius of curvature, so which means smaller than 4 centimeters. The mirror forms an image whose distance from the object is 5. Okay, again, it tells us the distance between the image and the object. 5 centimeters. Not direct as the image distance. Is the distance between the image and the object 5 centimeters. Determine the distance of the object from the object to the mirror. So which means the object distance, absolute value of the object distance. Okay, when the image is real and be virtual. real and virtual. So first, let's look at when a real image is formed. Okay, when a real image is formed, my Q is positive. From on the left-hand side of the mirror. From on the left-hand side of the mirror. You know, when my object is placed within the center of curvature, so that the image should appear farther, you know, should be appear, you know, beyond C, so that it will appear farther from this mirror. So that this is the configuration we are looking at. This is the configuration we are looking at. Distance between the image and the object here is 5 centimeters. Object distance P, image distance Q. Okay, so that in this case, you look at this, you know, the bottom arrow here. You look at the bottom arrow here. So what we, let me see where I can get that. So what we have here, you can say what we have here. What we have here is the relationship between P and Q. So in this case, my object, this image distance Q should equal to the object distance P plus 5. Okay, should equal to object distance P plus 5 because Q here is positive. Both P and Q are positive. So that we substitute into the image equation. Substitute into the image equation. Q replaced by P plus 5. Okay, equal to 2 divided by the radius of curvature. Rearrange this, we can get a quadratic equation. So we get P equal to either 2.4 centimeters or minus 3.7 centimeters. So here we should only choose the positive side because we only have the real object. So corresponding magnification minus Q divided by P equal to this guy. Okay, you can say minus magnification, which means it's an inverted image. Absolute value larger than 1, so which is enlarged. Okay, it's enlarged. Now let's look at the second case. The second case when a virtual image is formed. As I said, when a virtual image is formed, it should be formed on the left or right hand side. Left or right. Virtual image. Virtual image should appear on the right hand side, okay? Virtual image for the mirror should appear on the right hand side. So because you know Q is a virtual image negative, then the real distance between the image and the mirror should be minus this image distance Q, right? Okay. So this real distance is minus Q. So that we should have P plus this minus Q, which is P minus Q equal to 5. So that this is the relationship between P and Q now. Now we just rearrange, change Q as P minus 5 into the image equation. Then solve it, we will get two positive numbers. One P equal to 1.3 centimeters. The other is 7.7 centimeters. So you can say now both P are positive. Are they both valid solution or only one of them is valid? What do you think? What do you think? Which one is a valid solution? Or both of them are valid? Sorry? Both of them are valid or only one of them is valid solution?
One.
Which one?
1.3.
Why?
The 7.7 is more than 5.
Yes, very good. Because the question tells us that the object distance is actually smaller than the radius of curvature. The radius of curvature is 4, so that my P should be smaller than 4. Okay? This is according to what the question already stated. Or the other reason is here, what we want is a virtual image. Q should be negative. Okay? Virtual image corresponds to Q negative. If you have P equal to 7.7 and then Q is 2.2, larger than that, okay? This does not correspond to a virtual image, but a real image. So that only by P equal to 1.3, 1.3 minus a negative number can get us to 5. We get a virtual image, okay, negative Q, okay? Any question? So if no question, now let's look at, so first let's look at the correction lines. Okay, that's correction lines. Okay. So the correction length, maybe you find it's so the constant here. So if you look at you may find some constant here is unconfused. But here if you find it's confusing, okay. To solve the question, we have some simple way to do that. So now let's look at what are the simple way. So here we have the real point of a person's eye is equal to 60 centimeters. So object, the person want to see an object at a distance 25 centimeters clearly. What should be the focal length of this correction length? This correction length, and find the diameter of the length. Okay. So now maybe, so if you are not quite understand how the correction length works, maybe you can even find this question if I understand. But anyway, what I can tell you is you just take attention to some keywords of this situation. Of this question. What I highlighted for you here, is this one. Okay, is this one? This is what I would like to highlight here. The image distance, okay, the image distance is always equal to minus the near or far point. This always helps you for correctness. If you see the keywords near point of a person's eye or far point of a person's eye, this gives you a clear indication, okay, my Q is minus this number. And then, of course, the object want to see our object clearly at a distance 25 centimeters, okay, 25 centimeters. So which means my object P should be 25. Normally, the object distance will be directly given in the question. For example, the question sometimes says, okay, in a cinema, you want to see an object at infinity. Okay, and which means that my P is equal to actually infinity. And then give me the near point of the person's eye, ask you to find out the focal length of the correction length. This is how the question normally estimates. Okay, so normally the object distance will be directly given. For example, here we want to see an object clearly at 25 centimeters. So which means my object distance is 25. Then what's the image distance? Minus the near point or minus the far point. Always in this, always my image distance equal to minus the near or far point. Okay, then if you remember these two, conditions, two keywords, okay, first find out what the question is, what the object it is directly in the question. And then here I'm giving to the keywords far or near points. Minus the near point is the image distance. Because for correction length, we can only test about application of the image equation. So either I want to find out the object distance, image distance, or focal length of the correction length. As I said, object distance is given. We can only find out the image distance or the focal length of the correction length. As I said, if I want to find out the focal length of the correction length, we need to know both object and image distance. The image distance is always minus the far or near point. So if you bear this point in mind, object distance P is already given 25 centimeters. Okay, 25 centimeters. As I said, image distance equal to minus the near or far point. The question already gave. Okay, it's 60 centimeters. So that means my image distance here is minus 60. Minus 60. P and Q are both given, so that are both known, so that we can directly apply the image equation to get my F. My F is 42.9 centimeters. 42.9 centimeters in this case. And then corresponding diameter is 1 divided by F. Diameter of the length is defined as 1 divided by F, which is about 2.33 diameters. Okay, so you can see here. So as I said, once again, so if you want to understand how the correction works, for example, for far field, for example, for far sighted person, how do you use this focus mirror to correct his eye, correct the size, or for nearsighted person, why we need a complete mirror to correct that? You can refer to the lecture notes. But for the tutorial, I just help you to solve questions. For correction length, we only ask you to apply the image equation. Either use the image equation to find out the focal length of the correction length, or the near or far point of the person's eye. So which means use the near and far point of the person's eye corresponds to the image distance. because it's always minus q. Okay, so that you just remember this. Remember this guy. Okay, my image distance always equal to minus the real alpha point. That's okay. Normally the question can be easily solved. Okay, can be easily solved. Now, to have another example, let's consider a past examination paper test, and that's last year. Okay, or not last year, 1 year ago. Here we have a far-sighted person which read the newspaper 25 centimeters away from the eye. Then this 25 centimeters is what distance? For the question. 25 is focal point. With the help of a diameter equal to 2.3, this 2.51 is the focal length. But this 25 is what distance? Yes, very good. This should be the object distance. We want to read a newspaper. Newspaper is not become the object. You have to understand what this question refers to. We read a newspaper holds 25 meters away from our eye. So this should be the object distance. Object distance, okay? Any question? This 25 is the object distance. So normally, if we want to read, for example, an object placed in some position in front of our eye, or we want to read something, say something clear at a certain distance, this kind of word normally indicates is object distance. Object distance. So now this 25 should be object distance, okay? Okay? Diameter equal to 2.51, so 1 divided by diameter is f, so focal length is given. What we do determine the near point and the corresponding magnification. As I said, near point is actually minus the focal, the image distance. Minus the image distance. So P given as 25, f 1 divided by a diameter, I get 39.84 centimeters. So f and the P are given, I can find out what is my Q. I can find out the Q. Okay, minus Q is the near point. Okay, minus Q is the near point. Okay, you can say the near point is now 67.12 centimeter. 67.12 centimeter. Okay, corresponding magnification equal to minus Q divided by P, which is now 2.68. 2.68. So the final problem for the correction length, right? When we put a length glass in front of our eye, and then we see some object clearly, but that all corresponds to virtual imaging. Okay? It's a virtual image. We call correction as always for a virtual image. Okay, and then it forms a virtual image at or near or far point. This is what the correction has to do. Okay. Any question? Okay, so if no question, maybe I will spend the last 20 minutes talk about the most important, or technical question for chapter 2. Although for example the mirror, the property of the image was tested in some way, but for chapter 2, geometry objects, the most often tested question is this multiple lengths on the image system. This multiple lengths. Okay. So yeah, here is another question. I don't have time about the question. I don't have time to go through, but you take a look yourself. Okay. So the last part of the question I'm talking about the imaging by multiple lengths on the mirror. This imaging by multiple lengths on the mirror are quite often tested in the medical examination. You can say nearly every semester. I say nearly every semester there will be some question like this. So this is why, apart from the tutorial question, I will also talk about another 2 questions as an example. But as I said, for chapter 2, the most important tutorial question is this one. Imaging by multiple lengths. So multiple imaging by lengths in the viewer system. Okay. So this is extremely important type of question. You should take a look. You should try to understand. Okay. You should try to understand. So now I will spend the next 20 minutes. Go through this type of question. The lens and the mirror. So here we have a lens and we have a converging lens and a convex mirror. Okay, forming an image system. So that the distance between the lens and the mirror are 1 meter. Focal lengths of these two optical element are 80 and minus 50 centimeters. So this is why this is the converging length. This is a convex or diverging mirror. Object located 1 meters in front of the lens on the left hand side of the lens. The question asks us to locate the final image formed by light gone through the lens twice and describe the final image in terms of its magnification and orientation of the image. Okay, what does this question mean? So first we have to understand what does this question mean by locate the final image formed by light that gone through the lens twice. What does this mean? What does this mean? So this means the object first emitting light passes through the lens for an image. Okay, passes through the lens first time to form an image, and then this image will serve as the object of the mirror, so that it will continue propagate to the right. Once they encounter the mirror, it will be reflected to form a second image. Once the second image is formed, the light will reflected light will continue propagate to the left. Now go through the reflected light will go through the lens twice, the second time. So you can say light emitted here first passes through the lens. So passes through the lens once, reflected by the mirror, and then goes through the lens twice. So which means in this case we have three image formed. First image formed by lens, second image formed by mirror, and the final image reflected image, okay, formed by the lens again. Okay, so this is why the light will go through the lens twice, because we have three image formed. Two images, the first image and the final image are formed by the lens. There is an intermediate image, okay. The second step formed by the mirror. This is what this question means. So you can say, okay, there are so many thinking processes involved. And the unit part is very complex, right? But what I would like you to highlight for you, when you say this multiple image question, don't be worried. We under solutions. What we summarize for you is the recurrence method that can deal with all type of this multiple image question. So normally, if you just use what was presented in the lens and lecture notes, so what you will find, okay, in each intermediate step, you have to judge whether the object is virtual or real, and the image display is positive or negative, so that the whole process is very confused. But what I tell you here is now, this kind of method, okay, summarize for you. Then you can forget about whether the image from the intermediate step is real or virtual. You directly follow all the steps there. You can forget about judging whether the image is real or virtual, whether it's on the left or right hand side of the mirror or lens. So that is very complex. You directly use this one. You can forget about all the intermediate steps and direct to the end. Now let's look at what does this mean. So normally for the multiple image, the object distance in the first image step will be given. So that what we do is we start from the first imaging process, because of course focal length of all the lens mirror will also be present here in the question. So Fn, so which means my F focal length is always given. Focal length is always given. So that if we look at the first image distance, F1 is given, Pn is given, and then we can apply, the first image equation to get my Q1, right? Because my P1 is given in the question. My F1, of course, also in the question, we can directly get a Q1. Once you get a Q1, this comes to the most important step of this recurrence method. I need to use Q1 to get Q2. I need to use the image distance in the first imaging process to get the object distance in the next imaging process. How should I do this? As I said, this is the most important one. Everyone should try to remember this. My Q2, second, each object distance is always equal to the B minus Q1. What is B? D is the distance between the lens and the mirror. D is the distance between the first image element and the second image element. It's always a distance. If we have a class A, okay, then this D12 is the distance between lens 1 and lens 2, or image element 1 and image element 2. So that my P2 equal to this D minus Q1. Once you get P2, as I said, redo 1. You go to 1, because now P2 is now 1. As I said, F2 is always given in the question. Now P2 is given, F2 is also given. Right? We can get what is my Q2. Once you get Q2, we can use Q2 to calculate P3. We can use Q2 to calculate P3. What my P3 it is? P3 equal to D minus Q2. Again, this distance D is image element 2 and image element 3, or lens 3 and lens 2. D minus Q2 always give us P3. And the P3 is low and you redo 1. Right? As I said, F3 is always here. P3 given, you can get Q3. When you get Q3, you can continue to do 2, we can get P4. P4 is image element 3 and the image D here is like image element 3 and the image element 4. So when you do this, okay, you can forget about judging whether my object is the uniform image is on the left or right hand side of the mirror, or what is the sign. You can forget about this. When you use this strategy, always keep the sign of P and Q here. Don't do any absolute value. Okay? Directly automatic conversion to positive. Don't do that. If you use this equation, if you use this equation, if Q is positive or negative, you keep the sign as positive or negative. Then substitute into here. If P is negative, also keep it as negative. And to go to the next one. So on and so forth until the end, and then you can get the final image. You can get the final image. Now I will use this another 2 examples for you to illustrate this kind of a strategy. Okay. So first, as I said, start for all person here. Let the race go through the mirror twice before 3 image. You have my recurrence method 3 times. Okay. 3 times. Okay. In 3 period, we can get Q3. Q3 is what we want to get. As I said, start with n equal to 1. The first image distance P1 is given in the question as 1 centimeters. F1 is 80 centimeters, so as 1 meters, okay? F1 is 80 centimeters, which is 0.1 meter, okay? Both P1 and F1 is given. Substituting into the image equation, we can quickly get my Q1 is equal to 4 meter. Here my Q1 is equal to 4 meter. So if you use a standard method, you should say, okay, this Q1 is a real image up here very far from this side, okay, something like this. But now, as I said, if you use my method, you don't have to worry about whether the image and how they will be reflected by the mirror. I say Q1 equal to 4. I use Q1 to get my P2. As I said, how we get that is my P2 should be equal to D. Distance between image element 1 and the image element 2, so which means this is my D. This is, image element 1, this lens is the image element 1, this mirror here is the image element 2, their distance is 1. So 1 minus Q1 should give my P2 minus 3 centimeters or minus 3 meters. Okay, P2 equal to D minus Q1 minus 3 centimeters. Once P2 is given, now I look at the second image element, apply the corresponding image equation. So that here actually equal to 1 divided by P2. P2 already calculated in the previous slides, okay? Plus 1 divided by Q2 equal to 1 divided by the focal length of this mirror, which is minus 50 centimeters. Minus 50 is minus 0.5 meter, okay? You can say only Q2 is unknown parameters, then we get what my Q2 is minus 0.3 meter. Minus 0.3. Now you keep the sum here. We forget about where the image will located, with respect to the mirror. You still get my Q2 in this case, okay? In this case, then apply my recurrence method, okay? My P3, use Q2 to get my P3. use Q2 to get my P3. The way is to use the distance between image element 2 and image element 3, still the distance between the lens and the mirror, d minus Q2, okay? My d minus Q2, you can say, this now is the final image element 3, so the distance is still keep unchanged as 1 meters, okay? I use 1 meters to minus Q2, I can get my P3. Which is 1.6 meter, okay? Now, if you want to use standard method, you have to justify how the ray will be, where the ray will be focused, whether it's on the right or left hand side of the mirror. So that will be extremely complex. If you see from the ray tracing diagram, that will be more complex. But if you directly look at what I write in the equation both time, you can forget about how the ray diagram it is. Directly working through this recurrence method. Okay? So P3 equal to 1 minus Q2. Get 1.3 or 1.6, okay? 1.6 is my P3. So that go to the last imaging process, okay? 1 divided by P3 plus 1 divided by Q3 equal to 1 divided by the focal length F here is 0.1 meters. Then directly get my Q2 is 1.6 meters. Problem solved. Right? If you use this recurrence method, the question will become very straightforward, very easy. So that the final image, of course, here is formed on the left hand side of the mirror, on the left hand side of the lens. Sorry. So Q is 1.6. This 1.6 means my object is virtual. So sorry, is virtual. Image is virtual or real. So this corresponds to the real or virtual image. As I said, whether it's real or virtual only depends on the sign of the image distance. Sign of the last image distance. 1.6 is larger than there, which means here I should have a real image because my Q3 is larger than there. Whether the final image is real or virtual only depends on the sign of the final image distance. Okay? Intermediate one, you can forget about this. My Q is larger than there, so that this is a real image. This is a real image. Then whether it's magnified or inverted, we need to find out the total magnification. So that the total magnification is equal to, for example, the multiplication of all the magnification. So the first imaging process magnification M1 equal to minus Q1 divided by P1. Second image is minus Q2 divided by P2. Last one is minus PQ3 divided by P3. Multiply all the three magnification together, you can get the total magnification. A total magnification here. You can say here we get a minus sign. Minus, which means it's an inverted, okay, inverted. So because M is smaller than 0, so now the image is an inverted one. Magnitude is smaller than 1, so which means I should have a reduced real inverted image, okay? Reduced real and inverted image. Okay? Any question? Any question? Okay, so if no question, maybe I will use the last 5 minutes, okay, to go through. So here you can say, actually, I just give you some example. This multiple image system test that we are offering in the final examinations. But of course, I don't have time to go through all the tutorial questions I present in my slides here. So that you look at my solution yourself. Now I will just help you to go through the most typical one. So this one I will just skip you to look at the solution yourself. Okay. Still follow more the same procedures for this question. Now I will go through I think the most important one. I will just go through the most I will say tricky one. Okay, which was tested just 1 year ago. So here we have two converging lens 1 and lens 2, separated by a distance 50 centimeters. And the lens 1 have a focal length 10 centimeters, lens 2 have focal length 20 centimeters. Okay, as shown in this figure. Now we have an object placed to the left of lens 1. The final image formed by the two lenses is located at 25 centimeters on the right hand side of lens 1. Okay. The question wants us to determine the position of the object with respect to length 1 and determine the final image in terms of its magnification and orientation. Okay, so now this question is presented in a reversed way. Normally, we give you the object, want you to determine the position of the final image. Now here the position of the final image is given. I want you to determine where the object here is located. Okay. But anyway, you just apply my recurrence method in a reversed way. But this is very important. Okay, the final image here is given. This final image is placed on the right-hand side of length 1, 25 centimeters. Now, so which means this image to both length 1 and length 2 is 25, right? Because the whole distance here is 50. The whole distance here is 50. So that its distance to length 1 and length 2 are both 50. But now the case is, what should be my image distance? Or let me ask in another way. This image is a real or virtual image. Let me add here. This is the tricky part. So why I want to talk about this? Because there is some spec set here. This image is real or virtual image. Very good. Why? It's on the right hand side of length 1. Why is it virtual?
But it's on the left-hand side of that too.
Very good. Bear in mind, although it gives you is set on the right-hand side of length 1, but you should bear in mind, this image is final image is not formed by length 1, but formed by length 2. Okay, but formed by length 2. Although it's on the right-hand side of length 1, it's on the left-hand side is on 2. This image is formed by length 2, so that we should judge whether it's real or virtual with respect to its own length. With respect to length 2 in this case. Although the question talks about length 1, this is some spec the examiner said there. We should still keep in mind this image is not formed by length 1, but length 2. So that whether it's real or virtual should be judged from its position to length 2. It's on the left-hand side of length 2, which means it's a virtual image, very good. So which means my Q2. So of course we have two lengths, we only form two images. You should get the condition is my Q2 should equal to minus 25. Minus 25. So F2 is given, so that I use 1 divided by P2 plus 1 divided by Q2 equal to 1 divided by F2. I can get my P2 is about 1.11 centimeters. So P2 is related with Q1, okay? P2 is related with Q1. Because my corresponding multiplication, of course, I can calculate this way. As I said, P2 is related with Q1, is related with Q1. So that here I should have, sorry, this should not be, this should be 50, okay, not 25. P2 should be related with Q1, so Q1 equal to B, the distance between length 1 and length 2 minus P2, okay? The distance between length 1 and length 2 minus P2, so this should be 50, not 25, okay, minus P2, so that I get 38.89 centimeters, okay? Already get Q1, okay? Once I get Q1, F1 is also given the question, so that I apply the first image equation, I can quickly get my P1 is 30.46 centimeters. 30.46 centimeters. With the corresponding multiplication, M1 equal to minus Q1 divided by P1 equal to this guy. So that the total multiplication is actually M1 times M2 equal to minus 6.5 centimeters. Okay, so now Q2, you can say this Q2 is on left side, which means I have a virtual image. So of course, the corresponding multiplication here is also positive. As I said, for this, for a single length, the multiplication for virtual image is always positive, it's an upright one. But you can say if you compare the two lengths, now my multiplication is a minus. So which means although here I have a virtual image, it's an inverted one because of the cancellation two lengths. So as I said, virtual image is always upright, real image is always inverted, only upright for one length and one mirror. If you have multiple lengths on the mirror system, the orientation of the final image and the virtual image and the original object, okay, does not simply it is okay. The virtual image always upright, real image always inverted. Only this only apply for single lens and single mirror. So that for multiple lens, you need to see directly from the total magnification. Okay. So in this case, my final image is magnified and inverted. It's a real one. Okay. It's a virtual one. It's a virtual one. Final virtual image is magnified and inverted. Okay. I hope these two examples can give you already imaginable how should we apply the recurrent method to solve the multiple lens system. So that apart from looking at the other past examination question, I presented previously. Okay, so here I don't have time to go through the solution, but the solution will be simpler than this one. So I hope everyone you can take a look yourself. Apart from that one, I have another actual question. Okay, so this is just an example. Of course, it's much more difficult than implementation. Just to give you an example to rehearse my recurrence method. Here I have an optical system of 10 converging lines. Then these lines are identical. Focal length always equal to 8 centimeters. Distance between neighboring lines is fixed as 36 centimeters. The first object is located 12 centimeters in front of the last one. I want you to locate the final image and describe its property, magnification and orientation. Okay, here I have 10 lines. Of course, this question will be very difficult, much more difficult than the final examinations. But I think it's a very good example for you to digest the recurrence method. If you can use the method to solve this question, that's the likely results. And the solutions are good about this. So give you the solution. The final answer should be 24. Okay, 24 to the right hand side of lens 10. So you try yourself and see whether you can get the answer. Okay, see yourself whether you get the answer. If you have any question, I can still remain here to clear your doubts. Otherwise, the class can be dismissed. Okay, so that the tutorial solution. Okay, tutorial solution already. I stopped recording. Okay, already uploaded or in the file here. Okay, here already. So already appear here, so that everyone you can take a look. You don't have to copy from them. But I say I cannot upload this to NPM or Symfony in what you can do. Okay. So that's the flow question. Maybe today we stop here. Okay. The class can be dismissed. If you have any other question, I will still be here to review your doubts. So as I said, take a look at the solution, especially the multiple image question. That is very important. Test the copy the final decisions. If you have any problem, do remember right after the network consultation question. Okay. Yes.
The drawings of the
Question 5.
Oh, it's in the class.
Question 5 or question 4? 5 is the correct answer. In or MS-Team.
Oh, you put the.
You can see here. Yeah, here in the document.
Okay.
The file.
I'll just check.
Yeah, what's your question? Oh, yeah, but you can check. Yes. 怎么了？
太丑的这个 mirrors
，mirror 怎么了？
为什么这个H prime 会是 real？
H 它是 real。就我说的，对一个 single 的 last 或者 mirror，real 永远都是 inverted 的。
因为如果是这样的话，那个
对啊，这个是 inverted 的，是的。
但是为什么它在那个 virtual 的 site 会讲是 real？
这是谁的？不会啊 ，virtual 的时候是 erect，virtual 是 erect 的，这 real 是这个，它写反了，这两个应该写反了，应该是这个在这边。
所以这个写错了，这个是应该是 virtual。
就是 inverted 永远是 real，
inverted
永远是 real， 就是对 single inverted 永远是 real，virtual 永远是 upright 或者 erect， 也就是这个，也就是这样，所以 inverted 永远是 real， 然后 erect 永远是那个什么那个 for virtual， 这个是对的，没有任何问题。这个是对的，没有任何问题。就说是你的 image， 如果是对一个 single， 你看我们最后一个 example 就不是了，它的 virtual 它也是一个那个什么，因为它是有2个 lens 的。但如果你是一个 single lens 或者一个 single 的 mirror， 你的 real image 永远都是 inverted 的 ，virtual image 永远都是 upright， 这没有任何疑问。OK， 把这个记住了。So remember, OK，for single 啊，前提是 single mirror，single lens。那你所有的 real image 永远都是 inverted 的。OK， 然后 virtual image 永远是 upright。OK， 这个没有任何疑问，这一点啊。对，好 ，OK， 你看到，对，谢谢。OK， 没问题啊。Hello, for student on Teams, any question? Okay, so just one note. So for so someone of you talk about the recording tutorial. Okay, the recording tutorial is in the recording side. You can say week 1 and week 2 are both present here. Okay, are both here. Okay.
Hello.
Yes.
I want to ask about question 4.
Yes.
So the question 4, I do the question right. So the first one is the
Question 4.
Yeah, of the tutorial.
So the last one. Last question, right?
Yeah.
Yes.
Oh,
This one, right?
yeah.
Yeah.
Yeah, I ask about the science.
You also for what?
The science.
The sign. Which sign?
Yeah, so you know the first one, right? The first step, you take the real object.
Yeah, you get a Q1 equal to 4.
Q1 equals to 4, right? Yeah, I got Q1 equals to 4. But it's behind the...
Yeah, so this is why if you want to say it's behind, this will be my context. Forget about this, you are following the method. 1 minus Q, whether if it's selective, then it's selective. If it's positive, it's positive.
No, it's 1 minus Q to get this P.
Yeah, to get this P. This P too, to get this P. 1 is behind.
It's behind, right?
Yeah, it's
but then
behind.
because I thought if you are ignoring this, right, then suddenly this becomes the
Virtual
the object.
Yeah, virtual object.
It
So
becomes
this is a virtual object.
So are we talking about virtual object is always negative sign?
Yes. This is the reason. But I will say, when you solve this question, you don't need to understand why. If you do, just follow my criteria. If it's real, it's real. If it's positive, it's positive. If it's selective, it's selective.
Then
you don't have to judge from the real location. That will, or
So
judge from the real size. But that will make the solution very simple, very neat.
If I can deduce from drawings the question that the final image is gonna be real or virtual.
This is the real.
Then
Normally this is what the lamp studies should do. But I would say that is very complex. This is much simpler.
By just following the sign.
You just following sign. You are correct. Very clear. I say the sign is already present here.
Yeah, because what I did was I didn't go and because I know that the image is 4 meters away from land, right? It means I deduced that it's 3 meters away from.
No, minus 3. Should be minus.
Yeah, I didn't think it's minus 3 because I thought, okay, I'm treating this as an object now.
This is a virtual object. A virtual object should be minus 3.
So I think this is 3. Then I do the.
I know. This is why I think once. Also, this is why I give this method because in the past many students found out, a lot of students, I mean 80% of the students will make such a mistake. They have a virtual object, but they still choose positive P.
Yeah.
Because virtual object is very confusing. So then I say, okay, you forget about especially talking about whether the object is real or virtual. You directly keep this on here. And then you can forget about whether judge whether the position of the object is whether it's virtual or real. So this will be much simpler.
Okay.
But you use this to solve, you can solve it very quickly and with 4 mark.
Right. Okay.
Yeah, the reason this is because we form a virtual object.
Okay.
Virtual object on the right hand side of this, of this
Yeah.
mirror, and then it's selected. This is the real size.
So if we just look at this, right, then we can just say the light showing left to right.
Yeah,
Then
from
if the,
left to
yeah,
right.
then if the image appears on the right
On the
side,
right, we
it's
have a
always
virtual
negative.
object. Yeah, always selected.
Always negative
Always
is on the
selected. Yeah,
right
yeah,
side
yeah,
of
yeah.
the thing.
That's right. That's right. This is real size.
Okay.
This is
Okay.
real size. But as I say, if you follow this method, you don't have to judge from this.
Yeah, but if it appears on the left side, like the image.
Yeah. For example, this is a focus at 0.4. So it's
Yeah.
not for example 0.4. Then it's focused somewhere here,
Yeah.
somewhere here, and then the image here is on the left hand
So
side of
it's
the
real,
screen.
it's real.
Yes. That will be real because, for example, here you become 0.4.
Yeah,
One
but-
is 0.4,
okay.
also a positive number.
Yeah,
Real
but
object.
in the end, even if it appears here, right, then if the final image appears on the right side, then
Also, the final image, which means the final image.
like no, like let's say, of course, from here already there'll be an image, a virtual image that'll be produced here, right?
Let me see.
Yeah, like here, of course, after you.
Yes, a virtual image are produced here. Yes.
Yeah. So
Yes.
how come do we have to do one more refraction on the lens?
Yeah, because the virtual image, you can say the virtual image from my light rays, forms back, it will go through the mirror
Oh,
and to form another image. It will go through this mirror again to form another image.
to form another
Yes.
image.
So even it's virtual image on the right, but it's formed by the extension of the, so real image always formed by extension of the real ray, right?
Oh, okay.
Virtual image. So which means the light ray is continually propagated from right to the left. It will go through the lens a second time
Okay.
to form a third image.
Okay, then let's say if this thing was different and the focal length was different of the lens and our image appeared in between.
Yes.
The first refraction, the real image appears here, and cause of the mirror, there'll be a virtual image appearing here.
No matter, yeah, because of the concave mirror, we will
Yeah.
have virtual image, yes, appear.
So do we have to take this virtual image and refract it on the lens again, or would that be the
Yeah, it will reflect on the last second.
again?
Yeah,
Is
you
it?
will have last second. If you have real image from
Oh,
virtual
okay.
image, the virtual image will still, continue propagating from right to left.
Yeah. Okay.
So we not always have a third image.
Okay. Okay.
So no matter the intermediate step is real or virtual, we always have
Okay.
a third image. So and the procedure will be unchanged.
Okay, so but yeah, then in the end, going back to the question 4, right, our final image was inverted at the back. This will be a real image.
Sorry,
This is a real image.
which one is the real image?
The very last one, our final.
This is the real image because my Q3, my Q3 is positive.
Yeah, correct.
My Q3 is positive, of course, it's a real image.
Right. Okay.
As long as my Q3 is positive, then it's a real image.
But we can deduce it's a real image because it appears on the left side of the lens.
Yeah. Because now my light is propagated from
Yeah.
right to left.
Yeah.
And then from right to left on the left hand side of the lens, and that is a real image. Yeah, that's the science.
Oh, okay.
Yes.
Because it's made by real rays.
Yes.
But this ray is behind the mirror though, so can you really call it real?
Yes, of course. This is the virtual image for the mirror.
Yeah.
But it's a real object for the lens.
Oh, okay.
Virtual image.
Oh,
considered
so
as a real ray.
this is the virtual object.
Virtual object. This is a virtual object for this mirror.
Mm.
As I said, but if you want to judge it, whether
Alright.
the situation will be very complex and confusing. So solving in terms of this way, you don't have you can forget about the real and the virtual, in the intermediate step. If you want to judge whether it's real or virtual, and then that's very confusing. And then easily you can make some mistake. But from this, if you don't have to judge and keep the sign clear, you won't feel make any mistake.
Right. Okay.
Because we don't have to justify whether it's real or virtual. Okay, convert the something like that. Okay, I would suggest you to go through this way.
Okay.
Okay.
Yeah.
You have any other question?
No. more already, I think.
You continue reversion. If you have just email me, or we can talk on Friday.
Okay, okay.
Okay.
Okay,
Okay, no problem.
Oh, what was the question actually?
Oh.
Why is this negative? The focal length? The,
The question is not selective. Question say it's selective and it's selective.
why am I negative? Is it?
Sorry.
But yeah, then is it negative?
This is a convex.
Yeah, so yeah, it appears over here on the right side.
Yeah,
So
yeah,
that's
yeah.
why it's negative, or is
Yeah,
it?
yeah. That's right. That's right. Because for mirror, concave mirror, the
Yeah.
focal length is negative. So if it says positive under them, which means there is some focal length. Because you can say for the sign conversion, I give you at the very beginning, right? So if the focal length, here. So if it's convex towards the left, and then it's a negative
Oh,
side.
okay, okay.
So that I here draw a convex mirror. If I give a positive sign, which means there will be some problem.
Yeah,
So
yeah.
this is a convex mirror. I give you negative, so which means. But anyway, you should follow exactly what is this question. Normally, so if even for example, lecture given here is a concave mirror, but if this here said is minus, you use what is given in the question because this is condition of the question.
Okay.
You cannot change it.
Okay. Can,
Okay.
can. Okay, thank you for.
No problem.有问题吗？还有？
没有问题。
确定吗？
对。
OK good。这上联可能没问题，上联可能就有另外一个可能在里面嘛。
对。
所以你就是在这里，在策方可能需要再看一下，如果他们可能会要让你离开。那行，你们这个叫什么？你们就是在看有什么问题，然后就是周一下会来找我啊。好，看一下。今天的东西还好吧？有没有什么难度的？有没有什么问题？今天的。
今天的应该是没什么问题。
对，你们看一下 LAMS 也这 tutorial 的东西都还好 ，LAMS 你看有一些什么样的问题？就像我说，其实 summary slides 和这个就更重要，因为这东西是家庭生解题的。这样子，把这些问题学起来用嘛。
可以，我们可以应用你。
好的，好，行，那没问题了，我先走了。
没事，谢谢。
OK，拜拜。哎，这里还有两个学生。Hello, Daniel, Mingyang, are you here?
可以出了。
什么？就我截出这个信息。
他们应该不在。
不在啊？是吗？就你们还会上呢，其实人不来听，对吧？那这个看 video 更好。我这个结束了。End the meeting 啊。